Okay, so some objects hanging on a string, right? So here we got the 9 kilogram object. They're all labeled that way, right? Hanging on a string, and the maximum tension is 275 newtons. So let's make it 275 so we get there in the shortest time, right? And we want to accelerate this thing up from rest a distance of 24 meters. I think what we're going to do is we're going to calculate the acceleration, and then we'll have to do a little SUVOT problem over here. So we're going to do F equals ma here, SUVOT over here. Okay, so 9 kilograms, 275 newtons is the upward force on it. Okay, because that's the tension in the string that it's hanging from. The force down is going to be, let's figure that out. Its weight is m times g. So 9 times 9.81 is 88.29 newtons. Okay, now this is positive, this guy will be negative. F equals ma looks like this. 275 minus 88.29 equals 9 times a, right? Okay, so divided by 9, let's see, 20.7, so the acceleration is 20.745. It's a lot of 5s, meters per second squared, right? Now we're ready. We've got the acceleration. That's a positive acceleration, right? So let's SUVOT that. Okay, initial velocity is 0 because it's raising from rest, right? A distance of 24 meters. And then we just got our acceleration. So that equals positive 20.745 meters per second squared. And that's 5 repeating in case you care. I think the formula to use is, let's see, S is U T plus 1/2 AT squared. So 24 equals, and then this goes away to the bison, because the initial velocity is 0. So that equals 1/2 20.745 repeating times t squared. So let's go 24 times 2 divided by that. I'm getting 2.34 as the square of that, and then I need to square root that. And when I solve that for t, I get t is equal to 1.52. This is a cool number, 110111238. That's awesome. You don't often see that in a number. I guess with 3 sig figs it would be this. So in this case we solved a SUVOT. We solved an F equals ma, then we did a SUVOT problem. Some of them you solve the SUVOT problem and then you do F equals ma. You just never know.